Hey everybody, welcome to Old Cogen is Dead, Determining the Best Use of Biogas in a Dynamic Environment. I'm Adam Ross. This is WEFTEC Connect, or as I like to call it, WEFTEC in shorts. Hope you enjoy the presentation today. My contact information is at the bottom of the slide, along with my co-presenters. I would like to thank Steve and Christina and Jordan and Joe for helping out and providing their agency information to this. Please send me an email. I'm really curious to know if anybody's actually watching, and if you are, shoot an email to aross@brwncald.com and just say hi. I would appreciate that. That'd be a kick. So the agenda for today and what to expect are bold statements. I say that tongue in cheek. Market drivers and trends, and then 3 case studies which show how 3 different agencies have tackled what to do with their biogas. All right, Old Cogen is dead. This is the concept of continuously running a cogeneration system on municipal digester gas needs to be reimagined. Electric rates are shifting toward time of use. There are co-digestion opportunities which allow us to increase gas production and energy generation revenue. And as new technologies are being deployed and coming to market, wastewater treatment plants with anaerobic digesters and combined heat and power facilities must seek to exploit every opportunity to produce more power, produce it at the right time and for the right price. There are a few other drivers behind this. One is electric markets are changing again. And this is a statement specific to California, but we'll see this across the nation, which is that electric markets are deregulating. They're shifting toward customer choice. There are more renewables coming onto the market, and all of this is making for a very dynamic situation for the grid. And we'll talk more about that in the body of the presentation. The last piece here is vehicle fuel. And there's the well-known saying, the best time to plant a tree was 20 years ago, the second best time is now. If you had put in a biogas to vehicle fuel system 5 years ago and had been running it these last 5 years, you'd be paid off and rich. So that, the second best time to have that facility would be right now, and specifically on-site vehicle fueling. And I'll show you the economics and the grant funding behind what's driving that statement as we get into it. And I want to back that statement up right away with a chart here that shows the relative value of energy based on market conditions right now, it's specifically to California, but most of this applies across the country. So what you see on the y-axis is the dollars per million BTU of input digester gas into any one of these systems, either a boiler, a cogen system, or some form of vehicle fuel shown in green. And what you get here is if you're running your digester gas or biogas to a boiler and you're just making heat, all you're really doing is offsetting the commodity value of natural gas, which is only about $3 per million BTU. If you're running cogen, the value depends on your electric rate and the efficiency of your system, but you're going to be somewhere around $10 per million BTU. So cogen by far is a better use of your gas than just making heat. And then we get to your vehicle fuel opportunities, and you can see at the far right that there's almost a 4x value for doing on-site vehicle fueling compared to running cogen. And that's what's driving the statements. That's what's driving this dynamic market, and what's ultimately directing a lot of biogas toward vehicle fueling projects. So these market drivers and trends, there's a really interesting dynamic between electricity and vehicle fuel, where the value of electricity is more and more tied to when it was made, and that's time of use and your specific electric rate schedules. Vehicle fuel almost doesn't matter when it was made, but what really does matter is how it was made. And that's what's coming into play there, the different credits associated with making a vehicle fuel, whether through federal programs or through state programs. They want to know, what did you make that vehicle fuel with? Was it renewable? Was it diverted from a landfill? What's our carbon impact or carbon benefit of making that vehicle fuel? So this is interesting. It just sets up this interesting dynamic where electricity is tied to one thing and vehicle fuel is tied to another. On the time of use front with electricity, I want to show what we call the duck curve in California. And the duck curve shows the amount of power required from other generation other than solar over a 24-hour period. So what you can see is the belly of that duck at 2020 is showing that traditional forms of power generation, whether that's nuclear or natural gas, we don't have coal here, that drops off during the afternoon hours when solar is cranking. The problem is between 5 p.m. and say 9 p.m. when solar drops offline and there's a huge increased ramp up required of basically less renewable or non-renewable power generation sources. That's what's causing the emphasis on time of use, because the grid is less stable during that ramp up period. And our independent system operator here in California has to manage supply and demand very tightly over those hours. That time of use dynamic is now reflected in the rate schedules that we're seeing in California, and that I think will spread across the country. The traditional peak power price, especially during summer, used to be noon to 6. That's when power rates were the highest, because that's when we had the highest power demand, running air conditioners, lights in offices, etc. Now, the high, reflecting this grid instability as solar drops offline, the high price is now 5 to 8 p.m. or 6 to 9. It's later in the day. It's a new dynamic, and the interesting part here is utilities that have solar and we're counting on making money from 12 to 6 on peak power aren't going to make that anymore. Now the peak rates are when your solar is dropping offline. So you're less able to bank up the peak power credits with a solar power facility as you were 5 or 10 years ago. So an interesting shift there to keep in mind. Vehicle fuel is driven by a major federal program. That's the Renewable Fuel Standard. And the credits you generate there are called RINs. There are different grades of RINs or categories based on, again, how your vehicle fuel was made. In California, we also have the Low Carbon Fuel Standard, and that's implemented by our Air Resources Board. And the goal there is to reduce the carbon intensity of our vehicle fuels in the state. You don't have to be in California to get LCFS credits. As long as you've got a pipeline connection into California, you can make biogas and inject it in Texas and still sell in California and derive these credits. But those are the two programs that are really pumping up vehicle fuel right now. Now, these RIN values are market driven based on supply and demand. The blue chart or blue plot here shows the value of a D3 RIN, which is the RIN category you get from digesting municipal solids. That's the highest value RIN. And as you can see, it started in 2016 and ramped up through 2018. And that's when everybody's like, we got to do vehicle fuel. Since then, the values have come down a little bit as there have been some market factors that affect supply and demand. But that value remains strong. The D5 RIN is less valuable. That's right now what you get from co-digestion. So if you co-digest fats, oils, and grease or food waste in your digesters, you're going to generate a D5 RIN. LCFS credits are shown with these hash marks, and you can see that over time, LCFS is ramping up. So whereas the D3 RIN value has been coming down, LCFS has been picking up the slack, and that's looking like a really strong program. Again, these are market driven. That's why you see the rise and fall of values. It's a supply and demand market. But this is what's incentivizing the vehicle fuel. And you've got to have a stomach for it. So, when agencies ask, what can we take to the bank? The answer is, 10 years from now, the crystal ball isn't super clear. We can model what it's worth right now and make some comparisons. and expect that they will come down over time, but it is ultimately up to the market and the regulators to decide. So I'm going to circle back to the relative value of energy chart here and kind of dive a little deeper on the vehicle fuel side. So you can see the first bar in green is co-digestion. And so if you're primarily co-digesting and you're making a D5 RIN, the best way to sell your gas is through a fixed price offtake agreement. And that's going for about $10 to $13 per million BTU. If you inject into the pipeline, which is the next bar over, people ask like, well, isn't that essentially natural gas? And the answer is yes. And so what you get when you inject in the pipeline is the commodity value of natural gas, which is about $3. Then you get the LCFS value, which converted into this scale of dollars per million BTU is about 7. And then that D3 RIN is 14. So you can see that, almost 80, maybe almost 90% of the value you get from pipeline injection is based on environmental incentives, not the actual value of the energy content of the gas. And that factors heavily into a risk analysis if you're an agency looking at doing one of these projects. The 2 bars on the right are on-site vehicle fueling. And there, the value of the commodity is higher because you're offsetting the retail value of a vehicle fuel, such as diesel or gasoline. So there, at the pump, you're paying $2, $3 a gallon. And so the commodity value that we're showing for that gas is higher. And that's assuming that you're operating an on-site vehicle fueling facility, somebody's showing up and paying that $2 a gallon, which is a great value for your gas. And then you're stacking the incentives on top of that. So going back to one of those bold statements, the best value you can get for digester gas or biogas is on-site vehicle fueling, and that's demonstrated by the bar on the right. All right, got some case studies here, and these are 3 different agencies that have looked at what to do with their biogas. The first one is the city of Santa Rosa, and I've coined this the continuous improvement example. So Santa Rosa is in Northern California. They're a 15 MGD facility, 4 digesters. Historically, they made about 200 SCFM, cubic feet per minute of biogas. More recently, through high-strength waste co-digestion, they've increased their gas production by about double. Their old Cogen system was 3 existing Cogen engines, and those had actually been converted from engine-driven blowers into generators. They had natural gas blending with air dilution and no co-digestion, and that's a real familiar setup. There are a lot of treatment plants across the country that have basically old Waukesha engines that were a great system in the 80s and 90s, but are getting a little old. And so we're going to show you on the next slide here what Santa Rosa did to improve upon that situation. So shown in the middle is their new Cogen system. And when we go new on Cogen, we call it combined heat and power. That's the new buzzword. So they put in 4 1.1 megawatt Cogen engines. These are highly efficient, lean burn engines. It's a great looking facility. So did that project, had enough gas really to operate one of them. The intent was to increase gas production through high-strength waste co-digestion, which is the picture shown on the top left. So that high-strength waste receiving facility came online. Sure enough, we were able to double digester gas production there and operate 2 engines. I almost glossed over the point here of the big check photo, which is a self-generation incentive program grant opportunity in California that we were able to successfully get for City of Santa Rosa and take $2.5 million off the sticker price. So with operating 2 engines and still having 2 for standby, City of Santa Rosa added selective catalytic reduction to 2 of the engines to allow for them to operate on natural gas and meet current air emission standards. So they got more deployable power by running the extra engines on natural gas. And then the picture below doesn't look super cool, but it is super cool. It's a microgrid system. So they have battery energy storage and can now play in the Cal ISO day-ahead market. They can do demand reduction. They can basically deploy power, store power, and they're much more adaptable for what's going on in the energy market, whether that's time of use or demand reduction or day-ahead forecast elections. So really cool project. Co-digestion, great engines, natural gas blending, battery energy storage. Batteries, I'll just drill on that real quick. We're seeing the price of batteries come down. More and more agencies are putting in battery storage, whether coupled with cogen or solar. There are really a couple different levels you can play. One is, I'm calling it time of use gamesmanship. So that's buy low, sell high, right? Store power when it's cheap, discharge your batteries when power is more valuable. Then there's time of use gamesmanship with solar and cogen. And so that's renewably charging your batteries with solar or cogen and then discharging it at a more valuable time. Then there's demand response. So that's using your batteries to respond to a call to action and say, hey, we need you to drop load, and then you employ your batteries to do that. And then there's what I call serious microgrid. So that's getting in on the wholesale energy markets, doing more with the equipment you've got installed and telling your system operator, hey, you'll pay me more for dropping 4 megawatts off the grid tomorrow afternoon. So those are the different levels you can play out with a battery. So for each of these case studies, we've got a scorecard. I call it the old cogen is dead scorecard. So, you look at going from running old engines on digester gas, and what is new cogen or combined heat and power now? It's co-digestion, it's natural gas blending, it's battery energy storage, grant funding, and valuing electricity beyond just that moment that it's generated. So this is what we mean by old cogen is dead. Regional SAN is our next case study. The tagline here is that the benefit and risk is proportional to size. They're a much larger plant, over 100 MGD, 8 digesters, 1,600 cubic feet per minute of biogas production. So they actually don't even have on-site cogen. What? They have a power plant, a utility scale power plant, co-located on their site, and that's where for the last almost 30 years all of their biogas has been directed. With that agreement expiring in 2025, Regional SAN did a study to say, hey, what should we do now? So the results of that study are interesting. On the next slide here, we'll show you that, I just said on-site vehicle fueling achieves the highest value for biogas. But when you're as big as Regional SAN, they make enough gas to fuel 300 or more trucks per day. And so the logistics of getting that many trucks onto their site and fueling them, coupled with just finding a CNG vehicle fleet, or fleets that are that large, just, wasn't going to fit for the project size. So we ruled out on-site vehicle fueling. So the next step is, okay, what about biomethane pipeline injection? We'll upgrade our biogas, we'll inject it in the pipe. Well, this chart shows it all. When we ran the 20-year net present value, in the worst case, that project would lose almost $40 million. In the best case, they would come out ahead by $100 million. So $140 million spread between worst and best. In worst case, what is that? That's no credits, right? That's by the time you get this built, RINs are shot, LCFS is shot. Is that realistic? No. I mean, those credits aren't going away, but they're not guaranteed. The best case is the current credits are pumping for 20 years. And we know that's not realistic either. So, the actual value might be somewhere in between, but we don't have any control. And for an investment of this size, $140 million spread is not an acceptable amount of risk for an agency like that. So pipeline injection off the table. The recommended project, engine-based combined heat and power. It's the best value for biogas. It reduces regulatory requirements because when you use your biogas on site, you get an on-site use exemption from OSHA regulations around process safety management and risk management plans. This is an interesting risk factor that agencies need to think about if they're thinking about pipeline injection. OSHA has a 10,000 pound threshold. If you have more than that amount of gas on site and you don't use it on site, you get entangled in all of these regulations. So if you are that big, there's a benefit to using it on site with Cogen. So we're looking here at 12 megawatts of installed capacity, exhaust treatment and gas conditioning. We'll have state-of-the-art oxidation catalyst and selective catalytic reduction on that in a new building. The old Cogen is dead scorecard here. Doing co-digestion, increasing your gas production. We really had to get into power demand forecasting and time of use rate analysis. We needed to make sure that regional sand could use all of this power on site, which they can. They also have on-site solar, so we had to look at time of use there. We're doing highly efficient engines. And the real takeaway here is economies of scale. 12 megawatt system, your cost per unit output is a lot lower than if you're doing a 500 kilowatt cogen system. So this project makes a lot of sense. The last one is Fairfield Sassoon. And the tagline here is vehicle fuel is king if you have a buyer. So they're back to the size about of Santa Rosa, 200 SCFM of biogas. I'm calling this the not so old Cogen status quo. Fairfield Sassoon is already doing everything right. So the challenge in here is figuring out a way to do it even better. They have a Cogen engine. They already do co-digestion. They have solar and wind, and they have gas storage. So the real challenge here for us to see it was to see if we could do even better. Ultimately, there were two alternatives in our analysis that rose to the top. So new Cogen, the net present value is shown on the left, and on-site vehicle fuel, net present value shown on the right. So on-site vehicle fueling is edging out Cogen based on the assumptions that we showed earlier. You're selling it on site to a vehicle fueling partner with a CNG fleet. They're paying you, around $2, $2.50 a gallon for CNG, and you're racking up the credits. And in that scenario, on-site vehicle fueling looks really good. The other cool point is this is the net present value compared to status quo. So both of them have a benefit over the already good existing condition, which shows you that there is ground to be made putting in more efficient engines, even if you stick with Cogen. So our ultimate biogas utilization master plan recommendations for Fairfield Sassoon are to further increase biogas production via co-digestion, outreach to local industries, and find more organic feedstocks. Pursue a vehicle fuel partnership for on-site vehicle fueling. What does that mean? I mean, the first person you call is the solid waste hauler in your city or in your community. If you're city of Roseville, for example, and you operate the wastewater treatment and you operate the solid waste collection franchise, that's an easy partnership. If you're Fairfield and you're a special district and you overlap in different cities, it's a little trickier, but you figure out who's got the solid waste contract, you talk to those companies, and you see if there's a potential alignment there. If that partnership doesn't work out, Fairfield still has a great project. They can put in a new Cogen engine and pursue net metering tariffs and bill credit transfer to maximize the value of that time of use electricity. Their scorecard: increase gas production, really leverage time of use rate analysis, leverage net metering and the opportunities that are there for, in Fairfield's case, the ability to wheel their power from their wastewater treatment plant to their pump stations, and potentially a vehicle fuel partnership. In conclusion, in every case, the agencies that we worked with were able to find a better value for their biogas. And that means, I think that reinforces that old Cogen is dead, that concept of just running an engine, set it and forget it, doesn't maximize the value for your biogas, that there are ways to pursue co-digestion, energy storage, different outlets for biogas, such as vehicle fueling, to really maximize the value the wastewater treatment plant and to the ratepayers, which is cool. If all of this sounded super complicated and fancy and you're just flaring your gas, don't worry about it. Do something. We call the flare the flame of shame, and it's much better to do anything rather than just sit on the sidelines and wait. So that's, I think, the call to action based on what's going on in the world. I'm in California, where the sky is filled with smoke thanks to a heat wave and climate change. I think there is a real obligation for wastewater treatment agencies to make the most of their biogas. It's a renewable fuel. It's an asset. It'll benefit the ratepayers, and it'll benefit the environment. So thank you. Appreciate it.